Hey, YouTubers, Tazman here, bringing you a new series or mini series or whatever, depending on how long it takes us to do it. So we are going to be learning Java. So if you haven't already, I highly, highly, highly recommend that you go check out my Taz Teaches Programming Logic, because that's going to get you the basis of everything we're going to learn here, and you'll be able to, hit the ground running. Also, because we're going to be using Eclipse for our Java programming, it'd be a really good idea to check out my video on Eclipse and Java configuration installation. I can't remember what I called it, but anyway, those are two. Well, I think there's 5 videos in the programming logic. That's all it really takes to kind of understand the basis of programming logic, and then the single video on how to install Eclipse and Java, the Java JDK. And I'm going to, in advance, ask you to forgive me for any sniffing I might do or clearing of my throat. I'm a little bit under the weather, or at least my body is. I feel fine. So, like I said, please forgive me for that. I'll try to keep it to a minimum, but sometimes you just can't help it. All right, so let's go ahead and begin with some stuff about Java real quick. So Java is a programming language. It's considered a high-level programming language, which means basically you have your low-level programming languages all the way up to high-level programming language. And low-level programming languages, I believe we went over in my Taz Teaches Programming Logic, but just to give you a real quick idea, low-level programming language, as low as it goes, it's actually really easy to know the syntax of it, because it's either a 1 or a 0, or and that's all. That's extremely low programming language. Then we have some other low level that a little higher than this. Man. So a little higher than this is something called assembler. So assembler. So assembler is a fairly low level programming language. It's basically talking at the chip level. So this is the very, very lowest you can go, because all a computer understands is on or off. That's how memory is you either have a signal or you don't have a signal. And if we group those together, that's how we can tell the computer what we want it to do, because a 1 or a 0 doesn't tell it anything, so we have to kind of group those together. In assembler, you use really short little commands, such as MOV for like move, and JMP for jump, which is kind of like a go to, or I go to a certain section. And then you can also do like add and sub for subtract, sub, and stuff like that. So the lower the level that you are trying to do, the more complex it is to actually learn and to understand, because it's just a bunch of little either 1, 0 or some keywords. As we go up the scale, we run into programming languages which are considered, we're going to group them all as high, but high level ones are ones that are more like English. They'll have things that say, for next, something like that, or end, and then of course end. Well, maybe they have end, depending on the actual syntax of the programming language. You have things like print. You might have things like let's see, what else? Things like random, or it might be something a little shorter called RND or something. It's still a bit complex, but usually it's there's more commands that are more kind of Englishy, I guess, for lack of better words. And these would be like your C++. C is actually kind of in there too. You have Java, of course. You have Visual Basic. Yes, UAL, Visual Basic. And it's just tons of other, I mean, there's literally probably thousands of programming languages. And these are actually considered high level, especially when compared to this. So you have this whole scale here of your level of programming languages. So generally, if you really want to get to the nitty gritty, back in the olden days, they would use punch cards, and if there was a hole in a row, that was a 1. If there was no hole, it was a 0. And you would program using punch cards and then feed hundreds upon hundreds of punch cards into the computer. It had to be in a certain order, and then the computer would do something. Then assembler came out where you can actually talk directly to the chips, and you can say, okay, whatever's in this register of the chip, I want you to move it to this register of the chip, or I want you to add this in with this other register. So you're just kind of working with the registers. And then your high level usually is operating system level, where you're actually writing stuff that's pretty much very similar to an English type of language as far as that goes. So that is kind of the beginning. So if we have all these high-level programming languages like C++, C, Java, Visual Basic, there's Fortran, COBOL, Haskell, all kinds of, there's Swift now for the Mac and such. But if there's all these programming languages, why would you want one over the other? And that usually comes to the pros and cons, you know. Why would I choose Java over C++? I mean, C++ might actually kind of be more in medium high. Let's just say that. Because C++, you can actually directly interface with your RAM. You can access direct memory locations, and so it's very, very nitty gritty as far as it goes. As far as the language goes, though, it's pretty much same as C, or C's probably down here too. I think, I'm not sure, but you know, if you want that kind of focused in like a laser kind of thing, then maybe C++ is what you want. But Java is more of a friendly one, where a lot of the stuff is being handled. You don't have to worry about any of the communication directly with the hardware, which is also one of the cons of Java. When you're using Java to access memory, you're actually accessing memory via the Java VM, which is Java Virtual Machine. So if you look at it this way, this, for example, is your OS. Now, if you're looking at C++, we're going to divide this in half. Like C++, I can access memory directly. Let's just say this is memory, RAM. As an example, I can access the RAM directly. However, with Java, you're actually running in a Java virtual machine, right? So this is the JVM, and then over here's your RAM. So with C++, I could say access memory and give an actual memory address location and be able to access that memory. However, the JVM doesn't give me that same access. What I do in Java VA is I access the JVM, which in turn accesses the memory. Now, this leads us to two of the cons of Java, or two of the big ones that I've noticed and read about and stuff. Is one is you're not directly accessing stuff. This does increase security in Java because I can't actually access this. The JVM is, you know, what Oracle's writing for my Java virtual machine, and how it accesses is where a security vulnerability would exist. Mostly, for the most part, the Java itself can't access anything directly, so it's actually considered more secure. But that's also a con where you can't access hardware directly. And because this has to go through this extra loop, and even, you know, if I'm accessing the CPU, Once again, I'm accessing it pretty directly with C++, C++ and stuff. With Java, I have to access JVM. I have to tell the JVM, make a request to the JVM, and the JVM then accesses the CPU and passes it back. So this actually makes Java a little bit slower than C++, for example. But for the most part, for a lot of things you're writing, you're not going to really notice a huge change or a big difference in speed unless you've got something that's just really number crunching or something like that. So those are kind of the cons. So let's go ahead and talk about the pros. So one of the biggest pros of Java is it's completely free. You can download the Java JDK and the Java JRE, the Java Runtime Environment, or the Java Development Kit. If you do install the JDK, you also get the JRE. The Java Runtime Environment is actually basically what the JVM is. The Java Development Kit is all the Java files, class files, and stuff like that that Java developers write, or the people that develop Java itself give you, and that gives you access to those for writing your own code. So that's the number one, is it's free, completely free. It's pretty easy to learn because it's a higher level programming language. There's some syntax gotchas. If you already know lots of other languages, it could be a little harder to break out of some of the habits and things that you've formed using other languages. It's very case sensitive, for example. It's very picky as far as uppercase, lowercase. You need to be exact when you do that. Also, like I was mentioning with the JVM and stuff, and the Java Runtime Environment and JDK, is there is a huge amount of the Java API, or the class libraries that you use to, it's just really big, and it's just constantly growing. So a lot of times you might not have to write a randomization type thing because there's already a library for it, and you can find libraries for graphics and everything else. So it's pretty good there too. It's multi-platform, which means, you know, I can write one Java file here, right, and it compiles to my class file. But then, because the JVM is what's installed on other operating systems, so over here we have Linux, and we have Windows, and we have Mac. So because this is the same all around, Oracle is taking care of how the JVM interfaces with the hardware, which is that con. It's also kind of a pro, because I can write one Java class or whatever, I can write one program, and it'll actually run on Linux, Windows, and Mac, and on various other platforms and stuff. So it's kind of hybrid as far as it can actually go to multiple operating systems. And then the other thing is it's constantly evolving. So you know, like with Java 8, lambdas were introduced, and all kinds of neat functionality for Java has been introduced. So it's a constantly evolving language, and it's not brand new. It's been around for a very long time, and it's everywhere. You know, lots of vehicles use it in the programming of cars and stuff like that. So now let's just talk a little bit about Java itself. Let's go ahead and get rid of this window here. Oops, I did again. I just duplicated. Let's go to the trash can. There we go. So let's talk a little bit about Java. Now, Java is what you call an object-oriented programming language. So there's two basic types of programming languages. You have older programming. The standard for older programming was called procedural, which is PROCEDURAL, procedural programming. And then Java and some of your new ones, C# and stuff like that, are what you call OOP, or object-oriented programming. And procedural, just to give a quick idea, if this is our page of code, you know, we write something here, 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 here. You know, this is our lines of code. Procedural just says it simply starts at the top and goes to the bottom. When it hits the bottom, that's the end of the program. So once it hits this, it's over. It starts at the top up here and ends at the bottom. In object-oriented programming, you're looking more at individual types of objects. So you would have maybe an object here called car, right? You might have an object out here called character. In a game, maybe C-H-A-R. We'll just call it character, char. Actually, A-R-C-T-R. Okay. You might have something out here called dog. Now, the one thing about object-oriented programming is it also is technically procedural. It's just kind of an advancement. So a quick definition would be for procedural, it's a style of programming which operations are executed one after another in a sequence. In procedural applications, you create names for computer memory, locations that can hold values. For example, numbers, texts, text in electronic form. The named computer memory locations are called variables because they hold values that might vary. A single procedural program often consists of hundreds of variables and thousands of procedural calls. So, for example, we might have in our procedural program here, we might have it go and call another procedure out here, you know, like get taxes. And it'll do that, and then inside this it will run to the bottom, and then it returns to this point. We also, like I said, create variables, and this is in both of them also. Like we might say mynum equals 1. So we're assigning a location in memory that we're calling mynum, and we're giving it the value 1. And you do that exact same thing in OOP, or object-oriented programming. However, you're looking at things more as an object, and you might have your main class out here that actually accesses this class, and it could actually access multiple versions of this class. And we'll talk about it in just a little bit. So if we talk a little bit now about object-oriented, let's go ahead and the definition I wrote in my notepad here. Object-oriented programming is an extension of procedural programming in which you take a slightly different approach to writing computer programs. Writing object-oriented programs involve creating classes, which are these guys right here, classes, class dog, class character, class class dog, character, and car, right? Let's see, where was I? Creating classes, which are blueprints for objects, which is the object-oriented programming part, right? Creating objects from those classes and creating applications that use those objects. After creation, classes can be reused over and over again to develop new programs. Thinking in an object-oriented manner involves envisioning program components as objects that belong to classes and that are similar to concrete objects in the real world. Then you can manipulate the objects and have them interrelate with each other to achieve a desired result. So that kind of gives you an idea of the object-oriented programming part. So it's still procedural in the sense that I might create a car object, right? And maybe I have like a Mustang. So I create a Mustang object, and it carries everything. This is the blueprint, so everything that has. So now I can access a Mustang object, or I can access a Corvette, C-O-R-V-E-T-T, Corvette, right? and I can access that object. So these are both created by the blueprint or the class itself. And then we have objects, and those objects can have different attributes, which we're going to get into. They can have different different things that they can do, you know, top speed, they both, you know, move and stuff like that. So that's kind of object oriented. So let's see, let's move down just a little further in my notes here. So understanding how object-oriented programming differs from traditional procedural programming requires understanding of three basic concepts, and that's called polymorphism, inheritance, and encapsulation as it applies to the class as objects. Let's see, we're about 20 minutes. I'm trying to think if this is probably good enough for our first episode, or maybe I have one more little note here. Let's see, where is it? Actually, I might have. Did I read that one? Yeah, I did. So the last thing, I think we'll get into the actual those three things that we're talking about: the polymorphism, the encapsulation, and the inheritance. In our next episode, or maybe we'll only have time to do one of those because I kind of want to help you really understand it. But the last thing I have written here is in object-oriented programming grammar, an object is equivalent to a noun. So the car is, or this is the noun, right? And then any attributes of this noun, I could say color. So what's the color of the car? In fact, let's do just a quick other different one. This might make it take a little longer, but that's okay. We're going to use a dog, for example, and we're just going to have a dog class. So over here, we're going to have our dog class, or what we call our definition. So right here is going to be the dog definition, right? So this is the CLASS DEF, what is it? FINITION. Sorry how that looks. So this is the class definition. So this is what all of our dog objects are blueprinted off of. So the first thing, every one of our dog objects are going to have, for example, a name, right? So this is a definition attribute, a name. They're also going to probably have an age. They will probably have a breed, right? And maybe we could check if they're hungry. And if they're hungry, then we could do, like we said, methods are like verbs. So we could have something here called eat. Eat. And we could have maybe another one called sleep. These parentheses usually are how you would distinguish this is a method within it. And we'll talk about that more later. So now if I have the class definition, this isn't any specific animal, right? This is a dog class. So this is our dog class, but it's not any specific dog. But when I instantiate this, or when I create an object off of this using this blueprint, what it's going to do is it's going to create, let's say for example, create a Spike. Spike is a dog, so that's his name. His age, let's say, is maybe 3. His breed is a pug named Spike, huh? Right? A hungry, let's just say, no, he's not hungry, right? And then, of course, it will also get the eat method and the sleep method. Oops, the sleep method. So here's our dog number 1. So dog 1. So if we create another object, it's once again and go to that blueprint, and it's going to create another dog, and let's just call this one maybe CJ. CJ, and he is a terrier. Well, we need age next, which is 12. He's an old dog. He's a terrier. Terrier. Is he hungry? Sure, let's make him hungry. Why not? And then, of course, we get the eat and the sleep. So we can actually create as many of these dogs as we want using our class definition. So this is our class definition. These become our objects. OBJECTS. So we have two objects here. And each of these objects, even though they're related because they are dogs, they're also individual. They're their own dogs. This one right here is actually dog 2, right? So if I created these and I said, okay, if I wanted to access something about dog, or as we have here, this dog is hungry, right? So we could say in our program, we could say dog2.eat. And this would call this, it would call this function right here, in which it would tell it to change its food level or whatever to no. So all of a sudden then this becomes no, and the dog's not hungry anymore. Or we could say, we could ask it to print out dog2 dot name. And this isn't actual syntax, but we could tell something like this. So this is our object, and these are our attributes and the methods. So we're going to talk more about these and how to actually get information and set information, and how to protect information, because maybe once I've created a dog named Spike or whatever, I don't want anyone to ever change that by themselves. I want to have very secure way of changing that if they want to change it. Or maybe I don't want them to invoke certain functions that they can do all from the outside of the program. And that's where we're going to get into the encapsulation and stuff. And we'll probably talk about that in the next episode. So thank you guys so much for watching. I really hope all this made sense. If it didn't, feel free to ask any questions you want in the comments. If I made some, grammatic errors or syntax errors or whatever while I'm writing or talking, feel free to correct me. I'm not a perfect person, and when you're recording and commentating and trying to do this stuff, it gets really easy to get sidetracked or not kind of follow your correct train of thought that you initially thought you were going to follow. So feel free to correct me if I'm wrong in anything, and I'll even mention it that oops, I did a oopsie. But like I said, if you did enjoy this, be sure to leave a comment down below. Aside from that, comment, like, and or leave a like down below if you liked the video. Aside from that, comment, like, and subscribe. Follow me on Twitter. Check out my other channels. You can also check out my Discord. All the information should be in the video description. And that's it. We'll see you in episode 2 when we learn a little bit more and get more in-depth in these classes and stuff. So until next time, I'll be seeing you later. Bye.